we learnt about special angles. Now, on a test, it will tell you do not use a calculator. Now, what we are expecting eventually is for you to know them off by heart. But right now, you just need to know, oh, this is a special angle, cut, paste the fraction. How do I know what the fraction is? You check the fraction on your calculator. If you have a sharp, unfortunately, you do have to learn it off by heart. It has to be the fractions, not a decimal. Because then I know that you have used a calculator. So we are cheating the system a little bit. So no calculator may be used, and please note, we need to use the 1 over square root 2 and not the square root 2 over 2. That means I can see that it's the calculator. We then went on to reduction formula, where we saw that a graph repeats itself, and that was on a theta x-axis. Here I'm just using a normal x-axis, 0, 90, 180, 270, 360. And my reduction formula was 360 plus theta, 180 minus theta, 180 plus theta, 360 minus theta, or negative theta. The other thing that we reminded ourselves of, that cos was positive, all were positive, sine was positive, or tan was positive. Then I gave you a scenario where I asked you what is sine 30. 30 is one of my special angles. I want the fraction, which is a half. Then I gave you sine 390. I needed reduced, which is 360 plus theta. In that quadrant, it is positive. So I can just say sine 30, which we already know is a half. Sine 150 is in this quadrant. My reduction is 180 minus. How do I get to 150? I minus 30 degrees. It is positive in that quadrant. Positive sine 30 is still 1/2. And lastly, sine 210. Well, that's 180. 210 would be somewhere here. My reduction is 180 plus what? Well, it's plus 30, but in that quadrant it is negative, so my answer would be negative sine 30, which is negative 1/2. So we're going to practice a few more reductions. Then I'm going to practice some more reductions with special angles, and then we're going to see how it affects my equations. Okay. Erin, you're going to have to take a photo.
No, I haven't.
Okay, so the steps for the reduction, I just want to take this out because I didn't want to do it at the end. So check which quadrant it falls into. I actually realized that finding your reduction formula first is better, but you can do either one at the same time, and then find your reduced acute angle. And we are going to practice that now. So for yourself, and I do suggest you do this whenever you see trig questions, always draw yourself a little cast diagram. Today is Tuesday, group 1, 10.5, sorry, and it is the 6th of October. So I always suggest you draw yourself a little cast diagram with all the information you need. So here's my cast diagram. I know that this is all positive, sine positive, tan positive, cos positive. I know that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I also now know my reduction formulae, so I'm also going to write that in. 360 plus, and I'm going to change it to something different. That does not change what it means. It just means my angle is now called beta, not theta. That's the only difference. 180 degrees minus my beta, 180 degrees plus my beta, and 360 degrees minus my beta. Then I have two more that I might want to keep in mind, is that this can also be referred to as positive beta and this as negative beta. So whenever I have trig questions, I'm going to draw myself one of these just to keep track of all the information that I know about a cast diagram. So just a few, we're just going to practice reducing, and then we're going to practice using the reduction and the special angle. So just for some practice, only about 3 or so. Did I give you any yesterday? No, okay. Okay, number 1. Tan 315 degrees. Number 2, sine 750 degrees. Number 3, cos 135 degrees. Okay, so we're going to practice with those 3. I'm going to give you one more. So you would have noticed I've already uploaded a PDF that's got lots and lots and lots of practice for you in it. I've also uploaded the memo. So next week when you're at home and you're practicing, you can refer to that as well. You are writing on the 21st, and this is part of what you are writing on the 21st. Throw in some negative angles while we add it. So use your reduction formula and reduce it to an acute angle. So let's pay attention to the first one. On the board, please. 315, quadrant 1, 2, 3, or 4? 315, so if that is 270, then 315 has to be in quadrant 4. What is my reduction in quadrant 4? 360 minus, okay? Minus what gives me 315? 45. In that fourth quadrant, is tan positive or negative? Negative tan 45. And that is what I mean by answering a reduction formula. Which quadrant is it in? What is the reduction? What angle am I dealing with? Is it positive or negative? Which quadrant am I in? What is the reduction in that quadrant? What angle am I dealing with? And is it positive or negative? Now number 2 is even bigger than 360. So we know that 360 is going all the way around. 360 plus 180 is 540. Plus another 180 is 720. I still haven't gotten there. Okay? What do I still need to add to 720 to get to 750? 30 degrees. So my reduction would be the same as this sign. So it's 360 degrees plus an additional 360 degrees plus the 30 degrees. And am I positive or negative in that quadrant? So 360, 360 plus 30, positive sign or negative sign? Positive sign. So remember, every 360 degrees it repeats. Now try cos 135. Which quadrant? What's the reduction formula? What's the angle? Is it positive or negative? So which quadrant? What's the reduction formula? Which angle am I going to reduce it to? And is it positive or negative? Three more seconds for number 3. Okay, cos 135. Which quadrant do I find 135? What is my reduction formula?
90 plus 35.
No. You learned that in grade 11. So it would be 180 minus. Remember, we only use 360 and 180 as my reductions, okay? Grade 11, well, you learn the 90s, but that's a whole different kettle of fish. Minus what angle? Is it positive or negative in that quadrant? There you go. Is anyone not ready to do number 4? Okay, which quadrant is 330? 1, 2, 3, or 4? In quadrant 4. What is my reduction in quadrant 4? Fantastic. Is cos positive or negative in that quadrant? And there's my reduction. And my last one. I suggest you convert it to the positive angle first. Okay? So remember when we did negative angles, we found that we can go in the anti-clockwise direction, or we could go in the clockwise direction, but it took me to the same point. But those two angles together must be equal to 360. So if this one is negative 125, the positive angle would be 200 and what? Is it 235? There we go, 235. So the first step, convert it to the positive angle. And now I can do my reduction formula quite easy. Where do I find it? In which quadrant? Quadrant 3. My reduction would be cos plus what angle? 55 degrees. Is cos positive or negative in this quadrant? It's negative, so I would have negative 55 degrees. Cos negative 55. Yes, Jade? So what do you mean by the other way? So what did you write? And how did you calculate it? Gives you negative 125. So say again, sorry. Cos 180. Cos 180 minus 55. And you still got negative cos 55. Thing is, you just always need to check the positive and negative nature. But because it's a repetitive graph, it should work. Okay, but that's fine. Just for me, to be safe, I like to work with positives, so I changed it to positives. Okay, but that is not the end of the story when we come to a test. Because as soon as I see a special angle, I have to do the conversion. Okay? When I say conversion, I mean cut the sign out and paste the fraction. So in my first one, is 45 a special angle? Yes. So cut tan 45 out and paste the special angle. We know that it's a special angle. I feel very uneasy and anxious. I can't remember what it is, so I'm just going to check on my calculator. It is 1. But I had negative in front of it. So my answer is negative 1. Sine 30, I can't remember right now because I'm so anxious. This test is making me forget everything. Checking on my calculator, sine 30 is 1. We crashed. No, we didn't. Hey, we didn't crash. That's amazing. Okay. Cos 45, checking on my calculator, just to confirm. But now, this is the tricky one because, remember I said don't give me that version. Give me the 1 over square root 2 version. So I would write negative 1 over square root 2. So you're going to have to drill this into your head. When you see this on your calculator, give me 1 over square root 2. So please write that down. We wrote it down yesterday as well, but we're going to write it down every day. If your calculator says square root 2 over 2, I want 1 over square root 2. Positive 30, cos positive 30, cos 30 is square root 3 over 2, and it's positive square root 3 over 2. Is cos 55 a special angle? No, it's not. So my answer, I would actually need a calculator to calculate. So not special angle, would need a calculator. Yes, just Irene. So to get a true value on that, we must use a calculator to calculate it. So I would go negative cos 55 degrees on my calculator. So negative cos 55 on my calculator. There is no other option. I would have to do it on my calculator, giving me negative 0.57. There was no way for me to know that other than doing it on the calculator. The special angles are technically without a calculator because they are special fractions. If you have a sharp, you are going to have to learn what those special fractions are. If you have a Casio, it gives it to you in fraction form, so you can cheat. Because it must be the fraction form. The sharp gives the decimal form, which is not allowed. So you're going to have to learn it off by heart. So I'm going to complicate it slightly, and I'm going to add multiple reductions and special angles into one question. So I'm going to take ones that we have just used. So now I've given you sine 750 times cos negative 135 times tan 315. And I'm going to tell you without the use of a calculator. So that is my indicator that I'm most likely going to get special angles, and I'm going to have to use the special angle fractions. So I'm going to do the reduction, do the reduction, do the reduction, all separately. So sine 750 was 360 or 720 plus 30, but we'll just separate it. So we went once around, we went around again, and we needed the extra 30 degrees. Cos negative 135, I am going to go with my cos positive angle, which is 225. And my tan 315, well that is, and again I'm just going to draw myself a little cast diagram because I have forgotten. That is 360 plus 360 minus 180 plus, no 180 minus 180 plus. 315 is in my fourth quadrant, so it is 360 minus, well, 45 gives me what I need. And now I'm going to check. Well, sine would be 360, 360 plus 30 would be positive sine 30. So I've checked the sign, the negative or positive. Cos 225 is in my third quadrant, which is 180 plus. 180 plus what? Well, it's plus 45. And it is negative in that quadrant. And then tan 360 minus 45 is negative in that quadrant, negative tan 45. I'm just going to get them all into the reduced reduction form, but you don't actually have to show this step. Remember, we are multiplying, so this would be cos 45, negative tan 45. Positive times negative times another negative. So I've sorted the signs out. Sine 30 is a special angle, is a half. The more you know off by heart, the less time it will take. And time is your biggest factor in a test. Cos 45 is 1 over square root 2, not square root 2 over 2. And tan 45 is just? So I did the signs first and then I changed it, and now I need to do my final multiplication. Top times top times top, so 1 times 1 times 1. 2 times square root 2 is just 2 square root 2. And that would be my final answer. And this could be up to 5-6 marks just for that. So you're marking every reduction, you're marking every sign, you're marking the change of the special angles, and you're marking the final answer. So it's a lot of marks. Now I could also ask this kind of question without special angles, but also expecting you to use no calculator. So for instance, I could make it cos 360 degrees minus theta times sine 180 degrees plus theta times tan negative theta over cos theta times sine 180 degrees minus theta. Now, if all of them are being represented by theta, they are all using the same sized angle. So it's just like when we multiplied by x's and y's. If they were all x's, we called them like terms. All y's, then they're also like terms. So in this case, every theta is the same value. We just don't know what that value is. But we can still reduce. Because this would be in which quadrant? 360 minus theta. Quadrant 4. And cos, is it positive or negative in that quadrant? So this can be reduced to cos positive cos theta. Sine 180 plus theta. Which quadrant is 180 plus theta? And is sine negative or positive in quadrant 3? Next one. Tan negative theta. Which quadrant is that? So again, it's quadrant 4. Positive that way, negative this way, so it's in quadrant 4. And is tan positive or negative in that quadrant? So negative tan theta. Cos theta is just cos theta. We can't reduce it any further. Sine 180 minus theta, which quadrant? Is sine positive or negative? Since my thetas are the same, sine theta divided by sine theta, the self divided by the self become, or the same thing divided by itself is just, not 0, not undefined, 1. 1 divided by 1 is 1. 500 divided by 500 is 1. Sine theta divided by sine theta is 1. So we can cancel if they are identical. So cos theta divides by cos theta. Sine theta divides by sine theta, but we need to remember this negative positive nature. And then we just have negative tan, which can't cancel with anything. So we have a negative times a negative, which is times my positive tan theta. Just at the bottom would just be 1. Don't even have to write it. My final answer is just positive tan theta. So can you see how I can still reduce and simplify even though there are no numbers involved? And this part we definitely can't do on a calculator. Your calculators cannot do this for you. So you need to know how to reduce even if there aren't numbers involved. Okay, we're going to move on to our equations. So like I said, there will be lots of this for you to practice next week when you're at home. Please ask as you practice, but those memos and activity has already been put onto the group. And I can't stress it enough, you have to practice this. It is definitely in your test on the 21st. I've also just received the first copy of your November paper, and it's also in there. So there is definitely trig at the end of the year as well. Not yet, I'm waiting for Mr. Stassen to give us the official one. Okay, let's look at some equations. Now we kind of did equations the last time I saw you, and it was pretty easy. But now we need to realize that when we calculated equations last time, we only looked at one singular answer. But we've just noticed that there is a repetitive nature of these graphs, and therefore we could get another answer in another quadrant. So that is what we are going to look at now, is all possible solutions in the full 360 degrees. Just looking for the worded note. Okay, so our goal is still to isolate theta. So equations, our goal is actually, we actually call it a reference angle. How do we do that? By using linear equation rules. What is that? Obviously, take your loose over first. Then what's attached to the function over. Then the function itself. And that will give you your reference angle. Once we have our reference angle, so that will give us our reference angle. Once we have our reference angle, we have a secondary goal to find which quadrants we could use. Once we have the quadrants, we will also know what the reduction formula is for each of those quadrants. And only then will we solve for theta. So I'm going to start off simple rather than complicated because we are adding some extra stuff now. Okay, so we finish writing that. So my example is, I give you 2 sine theta minus 0,71 equals to 0. Theta is an element of 0 to 360 degrees, so that exists on the entire plane, and I want to solve for theta. Now we just wrote that we need to get a reference angle, and we do that by taking over what's loose first. This 0,71 is the loose version, so I'm going to take it over, and it becomes positive 0,71. Then I'm going to do what is attached to the function. I have 2 times sine, so dividing both sides by 2, I get sine theta equals 2, dividing by 2 should be 3,55, 0,355. Is sine positive or negative? Sine theta is 0,355. Is that positive or negative? It's positive. Now, in which quadrants do I find a positive sign? 1 and 2. So now I'm going to have to find an answer for theta in quadrant 1, and I'm going to have to find an answer for theta in quadrant 2. But I need a reference angle to know what I need to do with the reduction formula. So I'm going to take sine over, and it becomes my reference angle. Shift sine 0,355 because I've taken it over, and I have a reference angle of 20,79 degrees. Now that is my reference. I'm going to use that in quadrant 1 with the reduction formula, and I'm going to use that in quadrant 2 with the reduction formula. Let's do quadrant 1 first. What is my reduction formula in quadrant 1 if I have not gone over 360? It's just theta itself, right? Nothing has changed. So in quadrant 1, my angle is 20,79 degrees. Quadrant 2 has the reduction formula. So it is my reference angle. So quadrant 2 my reference angle, my theta, would be 180 degrees. What's the reduction in quadrant 2? Minus my reference of 20,79. So what is the true theta in quadrant 2? Well, I'm going to check. 180 minus 20.79 gives me 159,21 degrees. So what have I calculated? I have calculated that sine 20,79 equals 0,355. And I have calculated that sine 159,21 equals to 0,355. So they are sharing the same y value, but because they exist in 2 different quadrants, I need to calculate both options. We will do another one. We still have time. Let's take the following. Let's simplify it a little bit. Cos theta equals to 0,851. I'm still referring to theta in the whole Cartesian plane between 0 and 360. So is cos positive or negative? And in which quadrants is it positive? So when I do my equations, I'm going to need to do it in 1 and 4. Do I need to take anything over to simplify? Is there anything loose, anything multiplied to cos? No. So I can immediately find my reference angle. So can you see how I'm not calling it theta yet? Okay, I'm calling it the reference angle. So I would go cos, shift cos 0,851, and my reference angle is 31,68 degrees. Since it is positive in 1 and 4, I'm going to have to look at what it is in 1, and I'm going to have to look at what it is in 4. Quadrant 1, theta is just equal to 31,68 degrees. Quadrant 4 would be what? .360 minus my reference, which is 360, you don't have to write that, 360 minus 31,68 degrees. Checking on my calculator, theta is now equal to 31,68 minus 31,68, 328,32 degrees. What could I have also written? I could have also just written that it is negative 31,68 degrees, because cos negative is still the same as positive cos. In that fourth quadrant only. So what do we have so far? Let's do a quick summary. We need to know, is the function positive or negative? And then find the quadrants. Get your reference angle. And then we can just note that quadrant 1 would be theta is equal to the reference angle. Quadrant 2 would be theta is equal to 180 degrees minus the reference angle. Quadrant 3 would be the reduction for quadrant 3. I will now, so it will just be 180 plus my reference angle. And then quadrant 4, theta would be equal to minus the reference angle. But also note, we could just have the negative reference angle as well. So that is equations, and that is what I could expect you to do. But I can complicate this. I'm going to complicate it today and once tomorrow. Okay, so that was just our summary so far. Okay? Now what happens when I go and manipulate what's happening to theta itself? Remember, what were my steps? My steps were what's loose first, then attached to the function, not the theta, and then the function itself. There's nothing loose here. There's nothing attached to the function, so what's my next step? Loose first, attached to the function, then the function itself. So what's next? Pardon? I need to take over the function itself. So my reference angle is when I take over the function itself. So that's going to be shift tan 3, giving me 71,656 da 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 da. But wasn't that 2 theta? Okay, now keep that in mind. My reference angle stops when I take the function over. Tan is positive in which quadrants? 1 and 1 and 3. This is why you should draw your cast diagram. So I know that I need to go quadrant 1. But now I'm not going to have I'm not going to have theta equals 71,565. I'm going to have 2 theta equals to 71,565. Dot, dot, dot. So what would theta be? What do we need to do? Divide by 2. So theta would be 35,78 degrees. But I still have to do quadrant 3. I know quadrant 3 is what? Which reduction formula? 180 plus my reference angle. But it's not going to be theta equals, it's going to be 2 theta equals. So let's simplify first. So 180 plus 71.565 blah 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 blah. 251,565. But I don't want 2 theta, so I'm going to divide by 2. Theta equals to 125,78 degrees. So what have we done here that's different to what we did before? We kept the stuff by the theta isolated. So therefore, we're still looking at whether the function is positive or negative. One would be the bracket equals the reference angle. Quadrant 2 would be the bracket equals 180 degrees minus the reference angle. And quadrant 3, 180 plus the reference angle. Quadrant 4, 360 minus the reference angle. What am I referring to in this bracket here? Whatever we are given in that question. So if I give you theta plus 10 degrees, then this would be theta plus 10, theta plus 10, theta plus 10, theta plus 10. We'll do a few more tomorrow, grade 10s. But again, lots of practice in that document that's already on WhatsApp.